In this video, we're going to be continuing talking about the concepts for Lab 5. So, once you have practiced building your Lewis structures and you know how to utilize VSEPR rules, the next thing that we need to take into consideration for this lab is the trends for electronegativity. So, understand that electronegativity is basically a designated value that tells you how an atom can actually pull electrons towards itself. Understand that when we look at this table, these values have already been designed, okay? So there's nothing that you need to do. You don't need to memorize this. Only you have to look at this table. The most electronegative element is fluorine, which is in this side of the periodic table. The trend in electronegativity is that electronegativity increases as we move from left to right across a period in the periodic table. And it actually increases as we move up in a group in the periodic table. And then you can see that by looking at the values in the periodic table. But again, when it comes to electronegativity, don't memorize it. This table is provided to you in the reference list for exam, and as you can see, it is also provided for the lab. Now, why are electronegativity values so important? Because one of the things is that when electrons are going to have a difference in electronegativity, then they create different types of bonds. So understand that the bonds that we introduced specifically at the beginning of chapter 6, it is actually related to electronegativity. So this is kind of like giving a number value for the type of bonds that we have in molecules. Now, when it comes directly into electronegativity and types of bonds, understand that electronegativity differences in terms of the absolute value. So even if you subtract two numbers and you get a negative number, understand that the positive value is the one that is taken into consideration. It can tell you the type of bonds that you have in a particular compound. So to give you guys an example about that, the different type of bonds are non-polar covalent, which means that our electronegativity values are going to be between 0 and 0.4. You can also have a polar covalent bond, which is going to be values of higher than 0.4 all the way to 2.0. And lastly, if you have an ionic bond, the electronegativity value is going to be higher than 2.0 up to 4.0. Okay, so I keep on talking about, oh, there's a range for it, and this is how you calculate it. I'm going to use the molecule of ammonia that we have here. So understand that when I look at the electronegativity value for nitrogen, it has an electronegativity value of 3.1. Then I have hydrogen, which has an electronegativity value of 2.1. So the ranges that I'm illustrating right here is when I use, for example, say 3.1 minus 2.1. That is a difference of 1.0. So what that tells me specifically is that this bond between nitrogen and hydrogen is going to be polar covalent because the electronegativity difference is in that range. Since it's 1.0, then it's higher than 0.4, but less than 2.0. So that tells me that a nitrogen-hydrogen bond is polar covalent. Now, when we have a polar covalent bond, there are different ways that we can illustrate them. So these labels are only for polar covalent. We don't use them for ionic. We do not use them for non-polar covalent. When you have a polar covalent bond, you can designate showing the electronegativity difference between the two atoms by using these symbols that are delta. Delta means partial charge. Okay, so when you compare two atoms, the one that has the higher electronegativity value gets specifically a delta negative, and the one that is less electronegative compared to its partner in the bond is going to get a delta positive. So these are just illustrating how we show a polar covalent bond. In addition to that, the other way that you can illustrate a polar covalent bond is by utilizing specifically a vector arrow, and that vector arrow is going to go, the end of it is going to be at the least electronegative atom and is going to point towards the most electronegative atom. So that's why you see that the flat end is on the hydrogen and then the pointy end is towards the nitrogen. So these are illustrating the polarity of a bond. Polarity, we also call it dipole in chemistry, which means that you have two poles, a positive and a negative. And as you can see, it is just illustrating the electronegativity difference between the two atoms is specifically in a polar covalent bond. The reason why this is important is that when we determine the different types of bonds that we have in a molecule, we can actually determine the overall polarity of a molecule. So molecules can be overall polar or overall nonpolar, and that is going to be independently from the type of bonds that they have. Okay, please review the lecture videos going over overall polarity of molecules, okay, in order to solidify those concepts. Now, once we have determined the Lewis structure of a molecule, the type of bonds that it have, if it's overall polar or nonpolar, then we can actually discuss the next concept in the background, which is attractive forces. And attractive forces are going to be explaining how molecules are going to be interacting with themselves in the substance that they're in, because it could be in any state of matter form, or how they interact with other substances. The interaction of different substances through attractive forces is something that we don't deal until chapter 9. So right now, the attractive forces that we are discussing is if you have a substance and it's interacting with itself. So there are 3 different attractive forces that you guys need to be familiar with. The first one is going to be London dispersion forces, or just dispersion forces. Dispersion forces are going to be found in every single compound. Now, they are not the strongest attractive force for all compounds. Only nonpolar molecules specifically have dispersion forces as their strongest attractive force. Okay, so other than London dispersion forces, which actually come from the electrons circling the the nucleus, okay, and at some point creating a partial or temporary dipole, okay, just because of their placement in the molecule. If any molecule has electrons, it has dispersion forces, okay? But understand that this dipole that is created in nonpolar molecules is temporary. It's just because of electrons movement. So understand that it is not permanent, okay? There are molecules that have a permanent dipole. And those molecules that have a permanent dipole are said to have dipole-dipole interaction. So if you have a polar molecule, then their strongest attractive force is a dipole-dipole attraction. Okay? Lastly, the third type of attractive force is going to be hydrogen bonding. Now, when it comes to hydrogen bonding is a specific type of dipole-dipole attraction because there are specific determinations that make a hydrogen bonding happen. So, for hydrogen bonding to occur, understand that hydrogen must be bonded to elements that are fun. What are the fun elements that hydrogen needs to be bonded to? Fluorine, oxygen, and nitrogen. Okay? So, when this is happening, I'm just going to illustrate hydrogen bonding in the following molecule. So here we have specifically a hydrogen bond that is happening in ammonia. So the nitrogen in ammonia is here in the purple ball, and then the hydrogen atoms are in the white balls. So as you can see, my hydrogen atoms is bonded to one of those fun elements. Understand that hydrogen bonding is not a bond, it's an attractive force. And they are going to happen, let me just highlight it. The hydrogen bond specifically is in between, okay, the nitrogen atom and a hydrogen atom bonded to one of those fun elements. And in this case, because we have two ammonia molecules interacting with one another, that hydrogen bond is because the nitrogen of one molecule is interacting with the hydrogen that is in the neighboring molecule. And remember that hydrogen molecule needs to be bonded to the nitrogen. But again, here we have the same molecule, so understand that as long as you have the nitrogen molecule, that's what's going to interact with the hydrogen atom in its neighbor, and that's what gives rise to that hydrogen bond. Now, hydrogen bonding, dipole-dipole attractions, and dispersion forces actually even can explain in chemistry properties of different substances. In this lab, specifically, you guys are going to be exploring how those attractive forces are going to be affecting viscosity, which is the resistance of a liquid to flow. You guys will be exploring surface tension, which is the attractive force that is exerted upon a surface of a molecule that it is in liquid form, interacts with the liquid beneath. And lastly, solubility. And understand that solubility is defined as the amount of a substance that will dissolve given the amount of another substance. Okay? So in this lab, again, lastly, you're going to see how the attractive forces affect these three.